Hi and welcome back everybody. This is going to be homework 941. 941, that's the name of the homework, and then this is going to be problem number 3. All right, and we're dealing with a truck right here that's undergoing a change in potential energy and probably a change in truck's kinetic energy as well. So A is asking us, what is our change in potential energy? So there's a part B and part C, but let's just take it one at a time and we'll go from there. So I'm going to stay with all blue this time just because I'm tired of changing colors, but I will draw a better triangle. So here's our slope. Now this is going to be grossly not to scale because that 6% incline, or the 6-degree incline, is pretty small. So it's probably even less steep than that, but that's okay. So here's our truck right there. I know it looks like a car, and here's our truck right here at the bottom. And it has a series of values. Let's see. Our initial velocity, v initial, equals 12 meters per second. 12.0 meters per second. All right. The mass of the truck equals 15,800 kilograms. All right. What is going on? The angle right here, theta equals 6 degrees. And we've got changes in altitude. All right, so we have a height initial. So this is our h initial right here, and we've got an h final right there. So we're going to just go ahead and write them in. H initial equals 1630 meters above sea level, and the final height, I can't write today, final height, h final, equals 1440 meters above sea level. All right, and we also have a final velocity, v final, equals 29.0 meters per second. All right, all good stuff to know. So let's go ahead and take that and let's put that into solving for our change in potential energy. Now we described work that was done as being a negative change in potential energy. All right, but change in anything is really just final minus initial. All right, so the change in potential energy is going to be U final minus U initial. Now let's ask ourselves here, what kind of change in potential energy do we expect it to have? It starts up here, and then it ends up down here. What's going on? Well, we've got more potential energy here than we do here, so we should expect it to be going down a negative change in potential energy. But that remains to be seen. That's just kind of our prediction, so let's see what we get. All right. In fact, I'm going to... Well, that's all right. All right, so how do we state the potential energy at any one point? Well, that's going to be mgh, and if that one point is the final position, then we're going to call it h final. All right. We've got an initial potential energy as well. That's mgh initial. So if we plug some values in right there, we should be able to get a change in potential energy. I can see right here that I'm going to need a lot more space because, and in fact, you know what? I'm even going to do this. I'm going to take this mg here and here, and I'm going to factor it out front. So it's going to be mg times h final minus h initial. The reason for that is because that mass of the truck is going to be a lot, and it's going to be a lot of numbers that take up space. So I'm just going to put it once out front. So that mass is 15,800 kilograms, and of course G is 9.81 meters per second squared. Oh, I don't want to put an equal sign yet. Times, those are all times what? The final height minus the initial height. Well, that's 1,440 meters minus 1630. 30 meters right there. So that should give us our change in potential energy. And I think if we do this right, we're going to find out that that is going to be a negative change. What do we get? And just like our problem tells us, the answer that I get is negative 2.94 times 10 to the 7th joules. So with regards to potential energy, it's losing potential energy as it goes down the hill. That makes sense because you have potential energy because of your height. As you go down, you get less potential energy. All right. let's do, I am going to change colors for the second one here just so you can tell them apart. All right, let's look at part B right here. What's the change in the truck's kinetic energy? All right, change in kinetic energy equals what? Well, we don't know. So what is change in anything? That is going to be kinetic final minus kinetic initial right there. Kinetic final is 1/2 mv final squared minus 1/2 mv initial squared right there. So let's put our values in and see what we get. What's our mass? I could take the 1/2 times the mass and put that up front too, probably if I want, but that's all right. What's that? 15,800. I'm going to save space by not putting my units in. Times the v final. What's the final velocity? That's 29.0 meters per second. That value is squared right there, so don't forget to square that. All right. Minus 1/2 times the mass again, 15,800 kilograms, times what's the v initial, the initial velocity? That's 12 meters per second, and that value is squared. So what do we get for a change in kinetic energy? Change in kinetic energy. Well, I'm going to punch these in and see if you get the same thing that I get. Well, I get 5.51. If you do this in scientific notation, by the way, 5.51 times 10 to the 6th joules of kinetic energy. And so it makes sense that that should be positive because you have less kinetic energy here, but as you go faster and faster and faster and pick up speed, this mass picks up speed, it gains kinetic energy. So what it loses in potential energy, it gains in kinetic energy. Good. So, question. Is the total mechanical energy of the system conserved? Is it conserved? And explain either way. Well, what we want to ask ourselves is the amount of energy, potential energy lost going down the hill, is that equal to the amount of kinetic energy gained? Because if it was conserved, then that would mean that energy initial, all the energy initial, would equal energy final down here at the bottom. So we lose 2.94 times 10 to the 7th joules of potential energy. All right. Well, how much do we gain? 5.51 times 10 to the 6th times 10 to the 6th. So no, that's actually on the order of 10 less than this right here. Even though the 5.51 seems greater, times 10 to the 6th is less than times 10 to the 7th. So no, it is not C. No. Why is it? Because the change in, or the negative change in potential energy is not equal to, or you might say is more than, is not equal to the change in kinetic energy. All right, so that means you would think that if all this potential energy turned into kinetic energy, then it would be going faster because it should have 2.94 times 10 to the 7th joules of kinetic energy down here. But it doesn't. It has less. So what happened to it? Probably got lost to friction. All right, so that discrepancy between this and this right here tells us that there was some non-conservative work done to that truck, probably by friction, and therefore that that amount of work is not accounted for, so we say that it's non-conservative. So there you go. There's homework 941. That's problem number 3, parts A, B, and C.